Hey y'all, welcome back to another video. Today's first question is, if 12 is a factor of n, what other positive numbers must be factors of n? So first of all, say n, so if 12 is a factor of n, then everything that is a factor of 12 is also a factor of n. If we have the idea that 12 would be like 2 times 6, it would also be 3 times 4, it would also be like 12 times 1, and so on, so on. So that means that n might not exactly only have those numbers in that idea, but it's going to have all the factors that 12 has. So, taking that idea, everything, all the positive numbers that must be factors of n, not all of them, but there would be 1 other than 12, 2, 3, 4, 6. There would be, that's it, other than 12. Moving on to problem number 2, what is the greatest odd factor of 12,024? So, thinking about this idea, a factor of 12,000, because since 12,000 is every single number is made out of primes, not just 12,000. So, if every single number is made out of primes, the only even prime number that 12,024 clearly has, because it's even, is 2. And 2 times whatever else makes up 12,024, nobody knows. But, well, actually some people might know, but I don't. Everything else that makes up 12,024 is what we're trying to solve for, because that would definitely be odd, since 2 is the only even prime number. And so we're trying to look for that remaining raw piece of odd primes of 12,024. So how do we do that? We're going to basically, like those lemon squeezers, we're going to squeeze out all the 2's from 12,024. And how are we going to do that? We're going to start dividing. So 12,024, first time you divide, you would get 6,012. Divide that again, you'd get 3006. Divide that again, you get 1503. Hey, look at that! Isn't that odd? So, wait, that pun was actually not intended, but I'll go with it. So our answer is 1503. Moving on to problem number 3, how many positive integers less than 20 have exactly 2 positive divisors? So, this question is also sort of like a twist of the two above, like sort of combined-ish. Kind of. But this one also takes your mathematical logic into consideration, because what numbers only have 2 divisors? Since every single number has 1 in itself, if the number is not prime, take that into consideration. If the number is not prime, it's always going to have something else other than 1 in itself. So that means since 1 in itself is its first 2, that means that there's going to be more. So if it's not prime, it's going to have more than 2. So if we're taking that into consideration, only prime numbers have exactly 2, which is 1 in itself, because that's the only 2 divisors it has. So our first prime number, of course, is good old 2, as said in the problem above. Then we got 3, then we got 5, skipping 4 over, got 7, we got 11, we got 13, we got 17, and we got 19. When I said we got 11, though, I felt like one of those, car salesmen. Anyway, so how many do we have here? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 positive integers less than 20 that have exactly 2 positive divisors. Also, if you guys haven't noticed yet, I'm starting to do that, sort of other system, where I start writing the answer in, this cool galaxy pen I found on OneNote. So it'll be a little bit easier to distinguish from my work. So yeah, that's the end of this video. I hope you guys enjoyed it, and I hope you guys learned something new. And I'll see you guys on the next one. Bye!